Hey guys, Mr. Milton here. Today we're going to talk about perpendicular lines. At the end of this video, you should be able to write or identify perpendicular lines from characteristics in their equations, and you should be able to write the equation of a line when given information about a perpendicular line. Alright, so we're going to start this off kind of similar to what we did last time. I'm graphing these two lines, and so I'm going to graph the first line in this orange color. We're given the y-intercept of -5. So I'm going to go down 1, 2, 3, 4, 5. And the slope is 2/3. So I'm going to go up 2 over 1, 2, 3. Up 2 over 1, 2, 3. Alright, that should be enough for me to make my line. Use my straight edge. And try to make a line through there. Alright. First line done. Alright. Second line, yay for us, they gave it to us in slope-intercept form, and so my y-intercept is 1. My slope is -3/2, so I'm going to go down 3, 1, 2, 3, to the right 2. Down 3, 1, 2, 3, to the right 2. Okay, and then through those points, make a straight line. Alright. Okay. And so, these lines are perpendicular. What makes them perpendicular is their slopes. That's the wrong color. I'm going to write it anyway. Hopefully everybody can see this. What makes them perpendicular is their slopes. To be perpendicular, lines must have both opposite and reciprocal slopes. Okay, so example of opposites would be like 2 and -2. 1/3 and -1/3. -7 and 7. Okay, so opposites, one of them's positive, one of them's negative. Reciprocals would be like 2/5 and 5/2. -6/5 and -5/6. Okay, so reciprocals flip the numerator and the denominator. So opposite reciprocals would be like if I had 3/7 and -7/3. -2 and +1/2. Okay, these are what we need. We need opposite and reciprocal slopes in order for lines to be perpendicular. Notice that that's what we have here. The slope of our first line is 2/3. The slope of our next line is -3/2. These are opposites in the sense that one's positive and one's negative, and reciprocals because the numerators and the denominators are flopped. Alright, so now we have a section here that says determine whether the given lines are perpendicular or not, then explain. So again, we're going to be looking for slopes. We just care about the slope. The y-intercept is not important to us in this case. So the slope of our first line here is 2. It's already in slope-intercept form, so not much we had to do for that one. For our second line, though, we need to make sure that we put it in slope-intercept form before we try to call it perpendicular or not. We get 2y here equals -4x plus 8. Divide by 2. We'll get y equals -2x plus 4. Okay, so the slope of our second line is -2. These are not perpendicular. Okay, the answer is no, because they are opposite slopes, but not opposites and reciprocal slopes. They need to be opposite and reciprocals. Reciprocal. Okay. Number 2 here, we're given the slope of negative 2/5 right away in our second equation here because it's in slope-intercept form. Here I need to make sure I put it in slope-intercept form, so I'm going to subtract 5x from both sides. And so I'll get negative 2y equals negative 5x plus 8 divided by negative 2. I'll get y equals 5/2 x minus 4. So my slope for this next line will be 5/2. Okay. These slopes are opposite reciprocals. So the answer is yes. I'm going to write this in orange because a lot of blue around it. Slopes are opposite reciprocals. Okay. Positive and negative, opposites. 5 in the numerator, 5 in the denominator, 2 in the denominator, 2 in the numerator, reciprocals. Okay. Bring number 3 in, complete it for me tomorrow with your notes. Okay. Alright, so in this section it says write the equation of the line perpendicular to y equals negative 4x plus 3 that goes to the point 8, negative 3. This process that we'll have to do is really the same as last time with parallel lines. We're going to find the slope of the original line. We're going to find the slope of the new line. Okay? In this case, though, the new line is going to be perpendicular. Okay, in that case, it will not be the same. When it was parallel, the slopes were the same, but now that it's perpendicular, the slopes are opposite reciprocals. This is the only change. Then we want to find the y-intercept using the point and then write the equation. So here, they tell us that y equals negative 4x plus 3. So if our original slope was negative 4, we can go through the process and say, okay, we need to be opposite, which will be positive 4, and we need to make it reciprocal. Which, remember, as we've said, every whole number is just a fraction over 1, so the reciprocal 1/4. So the slope of our new line will be 1/4. The point that we're going to use is 8, negative 3. Plug it into our slope-intercept form, where our slope we know is 1/4. Our x value is 8. We don't know b yet. Y is negative 3. Okay. And now we just solve for b. 1/4 times 8, 8 over 4, or 2, plus b equals negative 3. Subtract 2 from both sides, and b will be negative 5. And so we have our new slope, perpendicular slope, opposite reciprocal slope, and our y-intercept that we just solved. So the equation for our new line will be y equals 1/4 x minus 5. All right. On the back side here, it says write the equation of the perpendicular to x minus 5y equals 20. All right. For this problem, remember that what we'll want to do is to find the slope of our first line. Okay, the difference between this problem and the last problem is that this problem is not in slope-intercept form to start, so we have to find the original slope. So we'll subtract x from both sides. Negative 5y equals negative x plus 20. Divide by negative 5. And we'll get y equals Be negative divided by negative is positive, so I'll say 1/5 x minus 4. The important part here is that finding that our original slope was 1/5. Okay, so from there, I'd like you to do our process and write the equation of this line. Write the equation of the line that goes to the point -2, -9. That's perpendicular. Alright. And then finally, this next problem, they gave it to us in just a different way, like as we saw in our parallel lines notes. Instead of giving us a written out description, they gave us a point in the line. Okay, so I'm going to use this line. I'm going to find out what my slope is. Up 2 over 1. Up 2 over 1. And so the slope of my original line was rise over run 2. And so the slope of my new line will be opposite reciprocal. So -2 reciprocal will be -1/2. So the slope of my new line is -1/2. The point that we're using will be -1, 2, 3, 4, 5. Up 1, 2, 3, 4, 5, 6. So -5, 6. Okay, and now I'm going to plug this stuff into the slope-intercept form. Okay, where I have my slope is -1/2, my x value is -5, my b I don't know yet, 6. So -1/2 times -5 will give us positive 2.5, positive 5/2, say that, plus b equals 6. Okay, I need to subtract 5/2 from both sides. Okay, in order to do that, I want to change 6 into having the same denominator. That'll be 12 over 2. So 12 minus 5 is 7 over 2. Alright, and so that gives me b is 7 over 2. It's a fraction. It's not pretty, but that's okay. We can use this to write our equation. Our slope is -1/2. Our y-intercept is 7 over 2. So y equals -1/2 x plus 7 over 2. That means it goes down 1 over 2, down 1 over 2, down 1 over 2. Okay, and 7 over 2 is like 3.5, so let's see if that makes sense. 1, 2, 3.5. Should cross right about there. Perfect. Alright, so that's our line. Alright guys, so through this video, hopefully you see how to identify parallel or perpendicular lines, through their equations, and how to write equations of a line given information about perpendicular lines. Alright, make sure you finish this problem, and also number 3 on the front to bring in with your completed notes, and I'll see you.